Hello, I'm David Kerr, Professor of Cancer Meds at the University of Oxford. You probably don't know this, but when I was a kid training in Glasgow, I trained in clinical pharmacology as well as medical oncology, my chosen medical specialty. In those days, all we had really were cytotoxic drugs, and it was unusual at that stage for people to apply, let's call it conventional clinical pharmacological principles to the delivery of chemotherapy. We had a fantastic group, the Pharmacology and Metabolism group. Some of the giants of European oncologic pharmacology were members of that, and we had a great time in those early days trying to link the pharmacokinetics, the pharmacology of drugs, to their side effects and efficacy profiles. There's a recent, I think, a very nice study, I wouldn't I, coming from a clinical pharmacology background, by a cooperative Dutch group, in which they've looked at using pharmacokinetic principles to improve the delivery of oral targeted drugs, predominantly tyrosine kinase inhibitors. They claim loosely that there's some correlation between exposure and efficacy. And what they've done is it's a large multi-center cooperative study. They enrolled about 600 patients, almost 500 of whom were eligible for the particular study that they followed. And what they did was they used some sophisticated population pharmacokinetic models that we won't discuss in detail at all, you'll be relieved to hear. But by taking blood samples serially on patients over the period of some weeks and months, they could adjust the dose of the drug to get it into what the literature suggested was the right range. So when we think about pharmacokinetic modeling, we think about two important dose levels, if you like. I guess there's the minimum acceptable threshold for activity, and above that, there's a threshold for toxicity. And between that, there's something that we call the therapeutic window. So we like to try and be able to adjust drug dose so it was within this window, avoiding excess toxicity up here and avoiding underdosing down here. Forgive my wiggly fingers, but that's the basis of it. It's a nice study. It was an ambitious one, 24 different drugs across a whole range of different tumor types. Impossible, really genuinely impossible to make any observations and correlation between pharmacokinetics and outcome, tumor shrinkage, progression-free survival, and so on. That just wasn't in the cards at all. But what they did show was that a significant proportion of patients, they were underdosed, so their plasma concentrations were below our minimal acceptable concentration. And by using this model in a multi-center setting in many Dutch hospitals, they demonstrated the practical possibility, the feasibility of using a pharmacokinetically guided approach to adjust drug levels to push them up to within our therapeutic window. But nothing, as I say, because of the nature of the study, the number of drugs, number of tumor types, it was impossible to correlate with outcome in any way that particularly made sense. But it did show that it was practically possible. It showed that a significant proportion of patients, almost 50%, in at least one of their readings, had drug levels that were considered to be too low. What else did we learn? So we talk about inter-individual variation. That's the difference between you and I. We metabolize drugs in a different way. But intra-patient variation seemed to be really important in this as well, because what they found was, by following patients serially, sometimes they were within the therapeutic limit, therapeutic window. Then in second or third readings, they were outside of it. So there is intra-individual variation, and that may depend on the time of day of taking the drug. Was it taken with food? Was there any concomitant medication? Were there any other physiological events going on, a whole host of other factors that, again, add to the complexity of the model. I would love to be able to demonstrate with clarity a clear concentration effect relationship between measuring drug concentrations in the bloodstream and outcome, and adjusting those in an individual way. It's personalised medicine. We talked about this before, but when you think about what we as doctors control, it's drug dose delivery. We can't control the patient's genetics. We can't control the somatic terminal mutational landscape. We can respond to it, but we can control drug dose. And if only we could do it in a cleverer way, perhaps using pharmacokinetic guidance, then that to me would be an optimal means of personalising drug therapy. And this Dutch study has demonstrated that it's practical, that it's feasible, and what we now need are much larger, well-constructed studies, I think, looking at outcome. The purists would say we should have randomized studies of conventional dose versus pharmacokinetically guided. I sort of agree with that, to be honest with you. If we really wanted to hammer down that it's worth the hassle of looking at these pharmacokinetic tests, I'd like to be able to demonstrate that outcomes would be superior, that treatment would be safer, and people would live longer and live better. So that's a challenge that I make to our PK community out there. Have a look at the paper and see what you think of it. I think a step forward, and it's reawakened in me that sort of old flame when I was a kid of all those years ago about wanting to do these sorts of experiments. Thanks for listening, as always, and for the time being, over and out. Thank you.